All right, so in this video, we're going to be taking a look at the classification of real numbers. All right, so this is more definition-based than anything else. So hopefully I can give you some tips and tricks on how to possibly remember some of these concepts and the way things are. All right, so I have here a rectangle. Ta-da! Rectangle. All right, and so with this rectangle, I have kind of going to make an illustration of how we can remember these classifications. All right, so first and foremost, every single thing that can go into this rectangle is called a real number. Okay, yes, there is such a thing as fake numbers. Okay, but real numbers are any numbers that exist in our realm of math. Okay, so anything that fits into this rectangle is considered real. All right, and there's then two big categories that deal in real. Okay, so we have what's called irrational numbers. Let's do that. Let's run out of room. All right, and on the reverse of that, we have what's called rational numbers. Now notice I cannot be rational and irrational. I'm either one or the other. I'm either one or the other. Both are considered real, but rational and irrational cannot be one and the same. Okay? Inside of irrational is nothing else. If I am irrational, that is it. I am irrational and I am real. And the two things that are considered irrational are pi, because pi goes on and on and on forever and ever and ever and ever and ever and ever and ever. Never repeats, never terminates. That makes them irrational. The other irrational are square roots that are not perfect. So in one of our lessons, we had learned that perfect squares, square root of 1, square root of 4, square root of 9, square root of 16, those are all perfect squares. They create perfect numbers. However, all the numbers in between, so again, I said square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. But what about the square root of 1, 2, and 3? What about the square root of 5, 6, 7, and 8? These gaps in between are irrational. They are not perfect squares, because if I type the square root of 2 in my calculator, I'm going to get a number that goes on and on and on forever and ever and ever and never repeats. Okay, so irrational can't be written as a fraction. They never terminate. And they never repeat. That's what puts them in their own little island. Okay? Rational numbers are the opposite of this. Rational numbers are fractions. And with fractions, we also have decimals and whole numbers. Okay? Now, things get a little bit more specific with rational as I move into this realm. Okay? So inside of rational, so I'm going to go ahead and make rational its own little circle here. Okay? And inside of this rational circle, I have another layer. We get a little bit more specific, and that is what we call integers. So we're going to go ahead and draw the circle first. And integers is when I have the introduction of negative whole numbers. All right, so here is where negatives come into play. A way to remember this is capital I can rotate over to make a negative sign. So integers is a more specific way of saying a rational number. And inside of integers, we have whole numbers. And this is where we have the introduction of 0. All right, and then inside of here, we have what's called natural numbers, because it's only natural to start counting with our positives. Okay, and the way we read this diagram is natural numbers, these positives, are inside of whole numbers. So whole numbers are also positive, which is inside of integers, which is also positive, which is inside of rationals, which is also positive. Whole numbers are not natural. Notice I cannot go down this, but whole numbers are inside of integers, so integers also includes the number 0, and rational also includes the number 0. And then integers, again, we can't go down, but integer circle is inside rational, so we also have our negatives. So notice natural is positive, whole numbers are positive and 0, integers are positive, 0, and negative, rational is positive, 0, negative, fractions, decimals, and real numbers are all of it. Okay. Another diagram that you can use, okay, is kind of this pyramid system. And this is kind of one that we like to look at when they're using the terminology of what are all of the categories. Okay. So natural is positive. He's at this top. He's this most specific. As I roll down the pyramid, I pick up my 0 with whole numbers. As I roll down, I get my integers of negative. And then as I roll down, here's where we have our fractions and our decimals. And then in its own island, we have irrational. So we have to understand the difference is rational. Any of these in this pyramid can be written as a fraction. Irrational, these cannot. These cannot terminate. These do not repeat. Therefore, they cannot be written as fractions. All right. So using this knowledge, all right, and this diagram, we can then classify these types of numbers. Okay, so here I look at it. Now, while it is negative and our brain first says, oh, that has to be an integer. This is a negative fraction. Fractions fall always in rational. So we would classify this first one as rational as his most specific. And then we list all of the rest below it. So he would also be real. All right, so I have 3 more listed for you. We have 3 pi, we have the square root of 96, and we have negative 4.2. Go ahead and pause this video and classify those numbers, and go ahead and push play when you're ready for the answer. All right, so some answers for you. This has pi, so this automatically has to be irrational, which also is inside of real. All right, square root of 96, or 196, if you forget how to type it in. Remember, it is second x squared. And then we type in 196 equals, so we get the whole number of 14. So that means this is natural, whole, integer, rational, and real. So when I have a positive number or a perfect square, I am all 5 categories. And then here again, while I have a negative and you would think integer, this decimal automatically puts it at rational and real. All right, so if at any point you need to rewind this video and rewatch, or to copy down one or both of these charts to assist you, please make sure you do so.